Hello, everyone. First of all, I want to thank everyone for making a time for attending first ever Open Cluster Management Community meeting. I'm Mike Yang. I'll be hosting these meetings every other week, except for the next one due to the winter holidays. And the recordings will be all uploaded to Open Cluster Management YouTube channel. For more information, please visit openclustermanagement.io. Today we have with us Michael Elder as well as Qiu Jian, and they're going to talk about open cluster management, and I'm going to let Michael give us a background on the origin and what is open cluster management and how it interrelates to the wide Kubernetes ecosystem. So please take it away, Michael.
All right, thank you so much, Mike. Let me start sharing here. All right, are you able to see my current screen?
Yes.
Yes.
Perfect. So I'll make this brief. The net of what we want to do with this particular project and community is to really focus in on this general problem that we find in lots of users' environments. They're beginning to create many clusters, and they're having challenges with, first off, how do they provision these clusters efficiently? How do they manage the upgrade lifecycle? How do they decommission them? How do they scale them up and down? So there's an aspect here of cluster lifecycle. We want to look at problems around how to manage the configuration of those things. So how to deliver configuration content in a consistent way, how to audit that, how to make sure that those clusters are compliant. We want to look at how to push applications to them. And there's some content that is part of the community that uses a GitOps approach to deliver both configuration or application parts to a fleet of clusters. And then we want to look at observability. How do we understand what's going on in those clusters? There's a lot of good projects. There's a lot of good other communities that are already part of the ecosystem of Kubernetes. There's work that goes on in SIG multi-cluster, work that goes on in SIG policy. There are projects like the Open Policy Agent and Argo CD that are doing great work in this space. We wanted to form Open Cluster Management in order to bring together a collection of different parts that could seamlessly present a consistent solution for users who are in this space or in this domain. So as sort of a background, there's technology that has been productized in a Red Hat offering. What we're really going to focus on in this group is not the product side, but really work in the upstream open community. And most of that product today has some parts that are open source, and there's a few areas that we are going to be working over time in order to make open source. It would have happened hopefully sooner, but 2020 obviously has been a very different kind of year for everyone. But we're going to look at areas like in this project, how do we register agents that are being managed by different clusters? How do we distribute work to them efficiently? These other problem domains that I described a moment ago. And work with the community, and where possible, collaborate back. Where can we add value to the specific areas like SIG multi-cluster or SIG policy or maybe the Argo CD community? Where can we help add value to those communities? This project, I think, at some point definitely will get contributed to a foundation. It is not the intent that this is wholly and solely driven by just one vendor. The goal here is to be very multi-vendor and to engage adopters and get real feedback. There are some resources that we've made available that talk about the overall architecture. There are some resources that will help developers get started adopting the upstream components. There are operators produced from Open Cluster Management that are already available in operatorhub.io, particularly around cluster registration and around distributing applications to those clusters. So today, Qiu Jian is going to take us through how that cluster registration flow works, because that's sort of the building block. If I'm going to manage a fleet of clusters, I need a way to link them together into one cohesive system and then take advantage of it. So with that, Mike or Qiu Jian, would you guys like to pick up the baton? I'll go ahead and stop sharing here. And I'll pause as well. Well, maybe Qiu Jian and Mike are coming up. If there are questions, do feel free jump in and ask those questions as well.
Like Qiu Jian, could you please talk a bit about the server foundation piece of Open Cluster Management, as well as he'll present us with a demonstration.
Yeah, sure. Okay, yeah, let me share my screen. Okay, yeah. So at first, as you have seen that this is a website of the the project, and there are some resources here that you can try to connect things like the repos, the mailing groups and YouTube channel, and also if you find something that is missing here, please let us know. I think I'm just going to briefly introduce what we have today, and do a small demo about how we do the cluster registration and distribute the workload. So at first, the things that we currently have open sourced with as a component is a very lightweight engine, which works in a hub agent model, that you will have control plane on a Kubernetes cluster and a set of the agent on each different clusters that connects to the control plane. And so with that, we were able to do some things that is basically to register the clusters, to distribute the resource manifest to the different clusters. And with these basic functions, we were trying to provide some basic APIs for the developers to implement a higher primitive or more complicated logic to manage the multiple clusters. So in our context, we define the hub as a resource called cluster manager and the agent as clusterlet, which is run on each clusters. So there were two main components in the cluster management, cluster manager and clusterlet, which we called registration and the work. The registration is a part that is going to register a managed cluster to a cluster manager, and it is going to ensure MTL secured communication between the cluster that has been managed and the cluster that works as a control plane. And also the registration is going to report some properties and status for the managed cluster to the control plane. Another concept, what we call is work, is to define a set of the resources that you want to apply or distribute it to a certain cluster. So you can define any kind of a list of any kind of Kubernetes resources in the work and on the control plane, and ask the work agent to apply that to a certain cluster. And there are some APIs here in the API repo, and this is the API repo. We have the managed cluster API that is going to represent a single cluster that has been registered on the control plane. There is managed cluster set to represent a group of the managed cluster, and cluster claim. So these two APIs is just to align with some current ideas and proposals in the kube multi-cluster, SIG multi-cluster in Kubernetes community. And also another one that would represent the work that we are going to be applied to the managed cluster is called manifest work. You can define a set of the resource manifest in the manifest work, and to ask the work agent to deploy it on the managed cluster. There are also another there are also another two APIs which called Cluster Manager add-on and Manage Cluster add-on. That is for the purpose of to support that you were able to register an add-on in the control plane and to be able to deploy an add-on agent on the managed cluster. So in general, that with these APIs, so it is possible that you were able to register cluster, you were able to deploy the resource into any cluster, and it is possible that a developer could be able to write an external add-on based on the current architecture. Okay, and then I will do a demo. So this is an environment that I have two kind cluster. Just to show the clusters that we have. There is a cluster named hub, and there is a cluster named cluster one. The cluster hub, so the screen upper is connected to the hub cluster, and the screen number 2 connect to the cluster 1. Yeah. Okay. So the first thing that we will need to do is to deploy the hub. We have a component which is called registration operator. It is an operator to deploy all the workload on different on the hub and also on the managed cluster. So we run the deploy hub on the hub cluster. So today it is using the OLM to register the operator onto the OLM and then deploy the hub component in the hub cluster. And after the operator has been deployed, we also create a cluster manager CR to start all the component on the hub side. So this is things that we just define the pull spec for the different image that we are going to use. Okay, and then I'm going to start the cluster spoke part. So we have another cluster which is called cluster 1, and I'm going to deploy the clusterlet on this cluster. So before that, we need to export several environment variable. So there are several environment variable that we need to export before we start the agent. The first one is called is a cluster name, and another one is the kubeconfig, which we call as the config to register to the hub, and for the clusterlet to register it to the hub. And let me check. Okay, so now from the condition, we can see that the cluster manager has been running and functional ready. And then since I've already export let me export again. And then we should be able to start the clusterlet. Yeah, okay, then you will be able to see a classlet CR has been created on the managed cluster. Yeah, and in the classlet CR, we need there's something that has been set, something like the cluster name, the namespace to install the agent, and also the image pushback for registration and work. So it will take, let's check the port in the, yeah, it will, oh, sorry. Yeah, okay, and it is being started. Yeah, okay, then after that the classlet has been started, you can see a condition that says it hasn't been functional ready yet because it is just the managed cluster to register to the hub, and the hub still need to approve that registration. So on the hub side, we should be able to see a managed cluster. That has a status that hub accepted as false. So the hub admin need to the hub admin need to manually accept that, which means that the admin on the hub actually accept that this registration. So just patch this managed cluster to make it true. And also there is another thing that need to approve is the CSR, because the registration agent will create a CSR, and the hub admin also need to approve that CSR. Okay, so after these two steps, you should be able to see that the managed cluster is ready. It has a condition like it is joined to the hub, and the status becomes available. There are some more informations that you might be able to see, like the versions of the Kubernetes, the capacity and allocatable of the certain cluster. And then we were able to create a work on the hub. The work, so when a cluster has been registered to the hub, we also create a namespace which has the same name as the managed cluster's name. So we have a managed cluster name of cluster 1, and the hub controller will also create a namespace cluster 1. And the work need to be created in the cluster 1, then such that the work agent should be able to fetch that work and apply on the managed cluster.
And Qiu Jian, can you clarify, just a quick question, can you clarify, is the distribution of work tightly coupled to the registration of this agent?
Okay, yeah, no, so yeah, the registration agent and the work is basically loose coupled. You can separately use each agent separately. In our cases, in the registration operator, we make them together because the work also need a hub kube config to connect to the hub, and we use a registration agent to generate that kube config for the work agent. But with other implementations, it is possible that to use the work agent independently by config the right kube config for the work agent. Okay, and
That's
then
awesome. So just to kind of clarify there, so you could choose to use the work distribution capability without having to use this particular registration protocol, and then you could use that to layer additional behavior on top of managed clusters. Is that correct?
yeah, that is correct.
Okay.
Okay, and yeah, and also I have a work here. The work is just so we need to define the work that with the namespace as the same namespace of the cluster. And in the work, we have a manifest part, and in the manifest, you could define a list of the manifest resources that you want to deploy on the managed cluster, cluster 1. So let me just apply the work. So after the work has been applied, you should be able to see that here, and there will be some status conditions in the work, trying to track the status of whether this each resources that has been defined in the work has been successfully applied on the managed cluster. So since we define 2 resources in the manifest work, and we have 2 conditions here, two types of the condition, each one for each resource. We check that whether it has been successfully applied on the managed cluster, whether it has been shown available on the managed cluster, and there's an aggregated status based on the status for each resources. And also, if we go back to the managed cluster, we should be able to see the things that has been applied on the managed cluster. So it is here. Yeah, I think that is all for the demo. Any comments or questions?
I think this looks good. Do you want to recap if you want to extend this work, where someone would go to get started? So here you've shown how to take advantage of it. Do you want to maybe highlight both how you might consume it through the operator catalog, and then maybe separately how you might actually extend it if you want to extend it with new capabilities from the actual repos in Open Cluster Management?
Okay, yeah. So we have 3 repos that for each component on the Open Cluster Management org. There's a registration repo that mainly for the registration, the work repo for the work, and there's an registration operator to deploy the components both on either on hub or on the managed cluster. So that could be used to deploy this simple engine. And also there's we have published it onto the operator hub. And if you have the OLM, you should be able to use the OLM to deploy the things directly onto the cluster. So to extend it, it is something that we really want to extend in the future. Like, for example, if we want to build an agent, an add-on that provide additional functions on the multi-cluster environment, like something like monitoring or maybe other things, you should be able to use a work to deploy your agent onto the managed cluster in a very simple way. And also, it is possible that we could have a higher primitive above the work and to say I want to deploy some workload onto multiple clusters with certain scheduling policy, and you could have a hub controller on the hub that decide which clusters you want to deploy the things and generate the work on each cluster's namespace to achieve that. So, yeah.
That's awesome. That's awesome. Are there any other questions or feedback?
I see that someone in the chat, Laura, you're working on a thesis on geo-redundancy. I'd love to know once you have a chance to look over stuff and develop your thesis. I'd love to hear presentation in this group because I think they'd be very interested.
Completely agree with that. Definitely. That notion of solving the problem of geo-redundancy is absolutely right in the swim lane of what we want to do with this project.
I want to share my screen and mention that what Qiu Jian has shown today is all available on the management website. So it's under the getting started, the install hub, and after you go through the install hub steps, there's the install cluster steps as well. Then you can get your hands dirty and try out what we have for open cluster management in terms of the cluster registration piece. And are there any other questions? Let me look in the chat.
I guess I have a question for the Ant folks on the call. Are you guys related to the Ant folks that are working on priority and fairness upstream in Kubernetes? Because we know those guys, and it'd be cool to see how you see these two things sort of fitting.
Yeah, probably we are in the different group, but yes, we are considering to consider using adopting OCM to resolve the multiple cluster issue we met currently. I already write a document to describe our use case and share it with Michael and Jian. Yeah, hopefully we could.
For that, Young Feng, perhaps we put that as a topic for the first call on December 7th, the next call, excuse me, January 7th, for the next community meeting. Maybe that's something we could put in. And then Laura, if you would like to come and talk to the group kind of about the use cases you're trying to address, that could be useful even if you don't kind of have all the moving parts as a solution. I think one of the things that we seek from this type of open collaborative effort is to make sure we all have a consistent view of the use cases and the problem.
Yeah, sounds great.
Are there any other questions before I end this meeting? Okay, with that being said, I want to thank Michael and Qiu Jian again for the great presentation. I want to mention again that the next meeting will be on the January 7th due to the winter holiday. I'm going to share again our community website and where you can get in touch with us. The Slack channel will be coming soon, and if you click on the community meetings, we'll have our agendas, and please feel free to write down your name in the attendance list. And that's all, folks. Thank you very much for attending.